How do we solve a two-variable equation? There are two methods of doing it. One is called the elimination method and the other is called the cross multiplication method. Now, the elimination method, we can do this. Say, for example, you have 2x plus 5y is 9 and 5x minus 6y is also 9. Now, elimination can be done by two methods. One is by substitution, one is by equating the coefficients. Now, suppose in both of them, ultimately, you're going to convert it into an equation of one variable. Let's see how. Now, look at the coefficient of x here and the coefficient of x here. It's 2x and 5x. So, suppose you make these coefficients equal. You can multiply this particular equation by 5. So, that 5 into 2 is 10. We need not to worry about this because our aim is to equate the coefficients of x. Now, to make this also 10, you multiply this equation by 2. Remember, when you're multiplying an equation by whatever number, see that all the terms are multiplied by the same. So, 5 into 2 is 10x. 5 into 5, 25y plus 5 into 9, 45. Similarly here 2 into 5, 10x, 2 into minus 6, minus 12y, 2 into 9, 18. Now we need to eliminate this. To eliminate this, we need to subtract. So when you subtract the equation, this becomes minus plus, plus of minus is minus, minus of minus becomes plus, minus of minus becomes this. So if you look at it, we have 25 minus 12 is 13y. I'm sorry. 25 plus 12y is 37y. And here you have 45 minus 18, which is 27. So y will turn out to be 27 by 37. And this value of y you substitute in any one of these equations and get the value of x. This is how we eliminate by equating the coefficients. There is another method of eliminating. In this particular equation, you can take, if you see 5x minus 9 is equal to 6y. Therefore, y will turn out to be 5x minus 9 upon 6. And this value of y we can substitute in the other equation. And this value of 5 is substituted in the other equation, you get 2x. We should not substitute in the same equation. If you substitute in the same equation, you get 9 is equal to 9. So, you can take the value of y or x from this equation, equation 1 and substitute in the second, or from second and substitute in the 1. So, you get 2x remains as it is. Instead of this, you write 5 into 5x minus 9 upon 6 is equal to 9. So this again would give you 12x plus 25, 37x, and we get accordingly the value of x accordingly and the value of y. So this is called by the elimination method. Now suppose you want to do the same thing by cross multiplication method. Another way, just for your information, name given to this is called Cramer's rule. So what we do is we have this equation as a1x plus b1y. And we take this 9 to that side and we call it as C1 is equal to 0. This is going to be called A2x plus B2y plus C2 is equal to 0. So if you see, we can write the same equation this way. 2x plus 5y minus 9 is equal to 0. 5x minus 6y minus 9 is equal to 0. So if you compare these two, this is like A1, B1 and C1. This is again like A2, B2 and C2. Now the first thing that you have to do is you take 1 upon 2 into minus 6. That is A1 into B2. So that will turn out to be 2 into minus 6 plus you have 5 into 5, that is A2 into B1, this will be minus A2 into B1, 5 into 5. This will get one equation. So what we have done is 1 upon A1 B2 minus A2 B1 is equal to x. x we take it, and don't bother about the coefficient of this. So same way here, look at x, and then you do 5 into minus 9. 5 into minus 9 minus 6 into minus 9. That is minus 6 into minus 9. So what have we done? It will be B1C2 minus B2C1 is equal to y. Again, for y, if you're considering the value of y, you omit this particular column, that is the column concerning 5y and 6y. And this time it won't be this way and this way. It will be first 5 into minus 9. That is A2 into C1. 5 into minus 9 minus 2 into minus 9. So if you look at it, this will become 1 upon minus 12 minus 25, that is minus 37, is equal to x upon minus 45 and minus 54, which will turn out minus 45 minus 54 is equal to y upon minus 45 plus 18. And you can cancel away minus, and ultimately you get 1 upon 37 is equal to x upon 99 is equal to y upon 27. So if you equate these two, you get x as 99 by 37, and if you equate this and this, you get y as 27 by 37, which is what we got by this method also. So I repeat this. Suppose you get an equation, a pair of equations, collect all the terms to one side and make the right hand side 0. Arrange the x terms one below the other. Arrange the y terms one below the other as we have done, and then arrange the c term one below the other. Then the first ratio is going to be 1 upon a1 into b2 minus a2 into b1. So it is 1 upon a1 into b2 minus a. Don't bother too much about the nomenclature, just let your fingers move that way. So you get this is equal to x. Once you take x, you don't look at the coefficients concerned with x. This is out of question. Then it is going to be B1C2 minus B2C1. So it's, in this case, it is 5 into minus 9 minus 6 into minus 9. Then is equal to y. Now you're looking at this. We don't consider these coefficients. But for y, what we do? We start from down. A2C1. In the previous one, we did this into this. Here it is going to be A2 into C1. But in this case, it is 5 into minus 9. Minus a1 into c2, that is 2 into minus 9. So hence we get these values, you get a ratio and then find the value of x. Now which method you would like to use, we can use as per our discernment, as per whatever it is. Ideally speaking, if you have an equation like this, 2x plus y is equal to 7 and 3x minus y is equal to 4, it makes a lot of sense to just do by elimination method, because the coefficient of y are equal and opposite. Just add the two equations and you get it. So it's a smarter way of doing it. So elimination, again, there are two ways. One is you equate the coefficients and cancel. The other is we do by substitution method. Only thing is, in the substitution method, we find the value of one variable in terms of the other, and that value of the variable you have to substitute in the other equation, not in the same equation. But if you look at both the elimination method, both of them practice the same principle of obtaining a linear equation in one variable, see, in the next step, so that ultimately you solve it as an equation in one variable, which will give you the value of one variable. Substitute the value of the variable in the other any one of the equations and you get the value of the other variable. So this is the basic principle behind how to solve equations in two variables. Let's see how we can apply these in all the examples that we have in hand.